Hi guys, welcome to the channel. Today we are going to start a new lesson called materials, metals and non-metals. In your surroundings, you have seen so many metals and materials which are made up of metals in your home also, like iron, aluminum, copper and so many other things. So please make a list of the materials which are made up of these metals in your home. Okay, either you may have a table or you may have a gas cylinder, you may have a fan, you may have a ceiling. So many things will be there, so many things. You may have a iron box, you may have a this water heater, you may have a oven, so many things. Okay, so you can make a list of non-metals also. Now let us look at this table number 4.1, appearance and hardness of materials. So take some examples of iron, coal, sulfur, aluminum, copper. How they look like? Do they shine? And what about their hardness? Are they very hard or not very hard, or are they soft? Right. So in most of the cases, you will be able to fill this uh, table. Then you will know that the metals usually have a shiny nature and they will be usually hard. Okay, so and rest of the metals like rest of the materials like sulfur is a non-metal. Okay, so just on the basis of their physical and chemical appearance you can say which is metal and which is non-metal. Okay, basically this lesson is to understand how to differentiate between metals and non-metal just by looking at them, that is physical properties. But later you will learn that physical properties are not enough, but today our topic of discussion is only physical properties of metals and non-metals. Now, have you ever seen a blacksmith beating an iron piece on an article made up of iron, like a spade or a shovel or an axe? You might have seen this with the blacksmith, that they are going to take any metal like iron and they are going to make a particular shape out of it, like a axe, like a spade, right, or like a shovel or like a kurfi, right. So they are going to give a definite shape for that by hitting them. So does it mean that you can bend the shape of a iron, we can bend the shape of the metal? Yes, obviously yes. Also you can see in this activity that we have taken these four things. One is iron nail, coal piece and thick aluminum wire and pencil lead. Okay, so what we are going to do is we are going to beat all of them with a hammer. Now what happens in all the cases? So iron nail, is there any change in the shape when you beat it with a hammer? Yes. What about coal piece? Is there any change? Yes. So does it break into pieces? Obviously yes. Aluminum wire, is there any change in the aluminum wire shape? Yes. But does it break? No. Pencil lead, does it change its shape? No. But does it break? Yes. Here iron and aluminum both are metals, but coal, which is made up of carbon, is a non-metal, and pencil lead is also a non-metal. Okay, so therefore you can see that the shape of the iron nail and aluminum wire changed on beating, but if you beat them even harder, their shape can be completely changed and you can change their shape into thin sheets. For example, in the bakery you have seen sweets, on the top of the sweets some silver color coating will be there, right? That silver coating is nothing but it is the aluminum foil which is made in the form of sheet. Okay, so it is beaten down in the form of sheet. Also you may get the aluminum foil which is used for wrapping of food. When you get food parcels and all, they are going to cover that food with a wrapper, and that wrapper is a very thin sheet of aluminum, and that is called aluminum foil. Okay, so aluminum foil is used for wrapping food, and you can there is no need to say that it is made of aluminum, right? So we understood that the metals can be beaten into thin sheets, and this property of the metals by which they can be beaten into thin sheets is called malleability. What is this called? This property is called malleability. So every metal on the earth has got this property of malleability. This is the most general property of the metals. So what about coal and pencil? Can they be beaten down into thin sheets? No, because they are going to break down. So therefore these are non-metals, and they are not going to break down, they are not going to form the sheet. So therefore you can say that the non-metals are not malleable, whereas the metals are malleable. Now there is a question for you. The question is that you take one iron rod, heat its one end, and you touch the other end. Will you feel the heat? Yes, obviously you are going to feel the heat if you just heat one end of the iron rod and just touch the other, because the heat is transferred, right? So the heat is being conducted by the iron rod. You take any metal, so what happens is they are going to conduct heat. This is one very good example for what you can say, that metals, they conduct heat. Okay. So one more example, in your home there is a frying pan, and that frying pan is made out of metal, and the handle, if it is not made up of any plastic and nothing is used, only metal is there, can you touch the hot frying pan while it is cooking? No, because the heat is being transferred from one point to the another point in the metal. So therefore you can say that metals are very good conductors of heat. So only if that handle comes with a plastic or something, then you are very easily you can handle it, right? So that's what it is, right? So on the other hand, the non-metals, do they conduct, are they good conductor of heat? No. For example, you can see that plastic protects you from being hurt. So therefore can you say that plastic and wood, they are poor conductors of heat, whereas the metals are very good conductors of heat. Now this is so obvious that there is an electric tester here, and for the electric tester we have a wires connected with the battery and a bulb. You can take a bulb, you can take a battery or a cell. Battery means it is a collection of cells. It's a battery, right? So we have a simple tester here which contains wires and cell and a bulb, and we have connected an iron nail into this. So when you connect iron nails, and you see that the bulb is going to glow, but at the same time if you just put some wood or if you put some plastic, then the bulb is not going to glow. It means that the metals are very good conductor of electricity, but non-metals are not good conductors of electricity, but they are poor conductor of electricity. Okay. Now one more activity is there. uh, so here iron, sulfur, coal, copper. In this iron and copper, they are going to conduct electricity, and sulfur and coal, they do not conduct electricity. So therefore we can say that the coal and sulfur are poor conductors of electricity. Now how do you find these aluminum and copper wires? Can you make wires out of aluminum, copper? Yes. But can you make the wires out of coal or sulfur? No. Right. So there is a property of metals by which they can be drawn into thin wires, and that property is known as ductility. That property is known as ductility. So what is malleability? Malleability is a property of the metals by which the metals can be beaten into thin sheets. And what is ductility? Ductility is the property of the metals by which they can be drawn into thin wires. So non-metals are not ductile, whereas metals are ductile. Do you know that just by using a 2 gram of gold, you can just make a wire, thin wire of 2 kilometers long? Okay, so that much is the metal is ductile. Now one more experiment you should do. That have you ever noticed the difference in the sound on dropping the iron sheet or a plate or a steel plate in your home, or a metal coin, anything, or you just take any take the coal or any wood in your home, which makes more sound? Or definitely the materials which are made up of iron or steel, right? Yes. So it means that metals are sonorous. What do you mean by sonorous? Sonorous means that the metals produce sound. When they hit any surface, they are going to produce sound, so they are sonorous. And what is lustrous? Lustrous means the ability to shine is called luster, or you can say the metals are lustrous. So therefore, after performing all the activities, we can say that the metals are generally hard, they are lustrous, they are malleable, they are ductile, they are sonorous, and at the same time they are also good conductor of heat and electricity. So the materials which generally possess or have these properties are called metals. Examples for metals are iron, copper, aluminum, calcium, magnesium. But materials like coal and sulfur, they are very soft and very dull in appearance. They do not have a shiny nature, and when you break them with a when you tap them with a hammer, they are going to break down. And they are not sonorous, and they are poor conductor of heat and electricity. The materials which possess all these characteristics are known as nonmetals. The example are sulfur, carbon, oxygen, nitrogen, helium, hydrogen, phosphorus, right? So these are all example for non-metals. Most likely non-metals will be gases, right? So one exception is there. Exception means ಗುಂಪಿಗೆ ಸೇರದ ಪದಗಳು. Okay, so it is out of context, out of the group. So metals like sodium and potassium are soft. What we learned? We learned that metals like iron or copper or zinc, they are very hard, right? But if you take the metals like sodium and potassium, they are so soft that they can be cut with a knife. And there is a mercury is a metal, and I told you that these metals, because of their rigid structure, they are generally or solid in nature. But mercury is one such metal which is found in the liquid state at the room temperature. In the room temperature, it is found at liquid state. Okay, this is the one of the exception of the metals. Okay, did you understand? I think you understood. Thank you guys.